No.
Maar je hebt hem daar. Nu? Waarom ik het zingen? Altijd gedaan. Toen heb je de stijl gemaakt.
The meeting has start. Are we ready to start? Yep. Hey, cool. Well, welcome everybody. Also our online participants and those who came here on site. Welcome to our presentation on game-based learning and game-based pedagogy, and also educational game design. Let me introduce myself. My name is S.Palha A.Bouwer. And we can working.
No.
Not today.
No, and this one also not. We'll start.
Luckily, I know who I am. I'm a researcher and teacher, lecturer at the Amsterdam University of Applied Sciences. I'm active at two faculties, the Faculty of Digital Media and Creative Industries, where I am a lecturer in the informatics field and game development, but I'm also working at the Smart Education Lab for the Faculty of Education. I have a background in AI and education. I'll give the floor to Sonia, colleague.
Hi, good afternoon. My name is Sonia Palha. I'm associate professor in mathematical education. I have worked as a teacher for many years at secondary education and also at higher education. And I did actually my PhD after I was already a teacher. And one of the things that really grabbed my attention was how to engage students in an active way to reason and learning mathematics, especially in collaboration with each other. I am present teaching as a teacher educator at the Amsterdam University of Applied Science. I do research on mathematical learning, but also on learning with technologies. And in the past years, I have been working with game-based learning and also with game-based pedagogy. And I am also a member of the program committee of the GAME. And GAME is a conference on game-based learning in mathematics education. The next session will be next year in Germany. So I'm already inviting you to go to this conference. And the plan for today is to focus actually on digital game-based learning and digital between brackets, because we also work with game-based learning without being digital, and also with the other area that is usually not so known, and it is about how you teach with games, and that is game-based pedagogy. And we prepared a Padlet to where you can use to pose your questions or to propose discussion points. And during the session, you can do that. And then at the end, we will go back to this Padlet and we will use it to, well, to discuss some things with each other.
Chance to take a picture?
Yeah, I think so.
Melody?
Okay, so I give you the floor.
Okay. I'll introduce you to the research themes of our research lab, the Smart Education Lab. We have several projects organized around a couple of research themes. One is interactive knowledge representations. That is the idea that students build a model that is often interactive in the form of a diagram. And we have different types of diagrams, causal diagrams, system diagrams. But the idea is that the system has knowledge of what the model should look like and gives you feedback while you're building the model to support you constructing your own knowledge and understanding how a system works. Computational thinking, a theme where you use the ways a computer can work for you also in human thinking, like decomposing a problem, thinking of a problem and a solution in terms of algorithms, stuff like that. We look at artificial intelligence and the current boom of generative AI, how to incorporate that in education in a meaningful way without cognitive offloading taking place too much. We have some colleagues working on the Makers Lab education, where people really build physical things. In this project, the Transit project that we're here for today, we also look at augmented and virtual reality. Learning analytics is the idea of using data about your students, or maybe also about your own course, to get insights about your education and improve it. But today, we'll focus on the last theme, game-based learning. And the focus in game-based learning is on the active role that students have in constructing knowledge. And they do that using games to play, but also to modify their thinking and create and elaborate on the knowledge presented through the game. And although there's quite a lot of research on games in education, a lot of it is focusing on quite shallow types of games and shallow types of cognitive knowledge, like facts and simple rules. But we're interested also in higher order knowledge that can be conveyed through games, and also more interesting types of games. so that you reach higher levels of understanding, but also things like strategic knowledge, reasoning on higher levels, and a lot of our work is focusing on mathematics teaching as a topic, that people also have a positive disposition towards mathematics. And we do that using two main research questions. How can we design games in a way that it supports learning? And how can we support teachers in using game-based learning? And through the years, we've done a couple of different research projects already. And these have even more specific research questions. Like we have had the Gamma project, also a European project, in which together with several European partners, we developed 7 different games for different mathematical topics. And there the goal was, how can games support mathematics education? In the Comenius project, game-based pedagogy, we looked at how can we support teachers in using game-based learning. So we really have to think about the didactics involved and what kind of competencies teachers need to make effective use of games. And in the Transit project, we looked at how we can use emerging technologies, AI, learning analytics, and augmented reality in teaching. In the Mega project, we look at mega games, and those are not digital, but games played in a physical location with lots of people, 30 to 50. And the main type of play is role play and discussion and negotiation. And we believe that this type of game can be really useful for higher education about multidisciplinary topics, involving multiple stakeholders, different viewpoints, conflicting viewpoints. And we developed a game about AI, the influence of AI on the world, and the related ethic considerations. The Mathify Me project deals with math anxiety, the fear that some students feel when they have to do anything with numbers or mathematics or formulas. And this is a problem that can arise already at a quite young age, but can get worse over time, and thereby influence people's decisions to go towards study topics that don't involve mathematics. So thereby it has a huge influence on your future life and career. And in addition, we do a lot of work with students of computer science, game development, that we tried to get involved in our research projects. So a lot of prototypes, game prototypes, have been developed in collaboration with students. And one of them was a game development student first, then a master AI student, and then a colleague, that is Erwin, who unfortunately couldn't be here today because he's ill. But at the top, you see the rest of our team, Daan van Smalen and Erwin van Krasbeek. And then I think I'll give the floor back to Sonia.
Okay, so what is game-based learning? And I'm sure if you are here today, it's because you have interests on game-based learning. So why would you actually use it in education? So perhaps you can take just some seconds to think for yourself about what would be the reasons to use it in your education, or at least in your future education, in case you are a student. So these are some of the motives that you can think about using games in education. So you can, motivation, it can be used motivation for learning, for doing things that you don't even like to do, or to keep on working harder even if you are tired. Knowledge acquisition, practice, also for cognition, but also it can also be used to change some attitudes. For problem solving, they are really nice games, that they are very challenging and that they force you to, well, to get out of the box and to try to solve difficult problems. Social learning, for example, multiplayer games, they are really successful because people have the need to, well, to be together. But also learning through failure. And actually, this last one is my favorite one because I hate failure. But when I'm doing a game, I don't have many problems to fail because I will try again and I will go on. And it is something that is very different from in the classroom. So as a teacher, I mean, I see that my students don't like to fail and they really feel uncomfortable when they cannot do things as well as they expected to. So that is for me one of the reasons, well, that I like games. So I don't know if some of you here in the room have thought about something completely different. Yeah. Well, if someone at home has thought about it, you can also put it in the tablet and perhaps we can at the end look at it because we are always learning. And I will give the word to Anders because actually about motivation and about engagement, there is a lot of things to say.
Yeah, there are several models about motivation in games, but we like to use this model, the Octalysis framework by Yukai Chu. And he recognizes 8 different core drives, which can be used to motivate people, not only in games, but also in other applications. He gives many examples on his website and in his book. But I'll talk you through each of them briefly. So one is the epic meaning and calling. That's the idea that you have an important mission to accomplish in your game, that you are contributing to a higher goal. And that makes you feel important and makes you want to play the game. So Wikipedia is an application that also tries to make you aware of that you're contributing to a large knowledge base, that your contribution is important. And you find the idea in many kinds of games where you have an important mission to fulfill, like save the princess or get the river clean again. Okay, number 2, development and accomplishment. That's the idea that you actually achieve something, that you make progress along the way. And a nice example here is the Strava app, which employs some gamification techniques to make you aware of your progress while you're doing exercise, running outdoors. And it's easy to see that you have reached a particular goal. They also set group goals that you can strive for. And it's easy to also share the results. But then we get into another one. We'll get to later. Creativity and feedback and empowerment relates to the idea of building things, creating stuff. And this, Lego is an important example where you don't even need a real game goal, but people are motivated almost by the bricks themselves to put them together and build new things. Also, the idea of creating your own avatar and dressing it up with nice colors and clothes can also be related to creativity. That may also tie in a little bit with ownership, because what is that you identify with stuff as if it's your own. And an important example here is the game Monopoly, where you buy streets, houses, hotels, and lots of money. And in games like Farmville and other things where you build your own environment and reap the benefits. Social influence and relatedness relates to how you feel in relation to other people, either by communicating, connecting. Social networks are an important example, like Facebook, if you ignore the advertisement part of it a little bit. But you can also think of comparing yourself to others. Like here's an example of an application that shows how your energy consumption is compared to your neighbors. And that may stimulate discussion among your community. But also feedback and thumbs up as comments to other people's contributions also relates to the social. This is a different one, scarcity and impatience. That's what you get when you make things scarce in your game. Time may be scarce, that time is running out and you have to reach the goal in time. Or maybe you have to find diamonds, but they are hard to find. Or the Pokemon. My son is really happy when he finds a really rare one, because that's worth more points, but it's also very special because you don't see that every day. And Sonia's favorite game, Wordle, there you have a challenge, but you can only do it once a day. So also scarcity. Unpredictability and curiosity. That's you can think of playing cards that you shuffle so that you don't know which one you're going to get, or the box of chocolates by Forrest Gump, or dice. This is an interesting example where a speed camera detects if you drive too fast, but if you drive slowly enough, then you'll be entered into a lottery. So to promote safe driving. So this all relates to that when something is unpredictable and it triggers your curiosity. What will happen next? Loss and avoidance. Avoidance is nicely characterized by Pac-Man, where you have to evade the evil four characters, the non-player characters, the monsters chasing you. But the other example is slightly more tricky, where you can get a streak if you continue to play, but you lose it if you stop playing. So then you try to avoid the loss. So something negative happening. And now we go to a little exercise that I want to do with you. Think about a game that you really like. Do you have one in mind? It's a digital one or a board game or whatever. Can I hear a couple of examples? Yeah. Dixit? Yeah. Whether you have to draw and talk, yeah. Any other? Bellagio, is that a board game? Ah. Okay. Any digital games? We don't. Tetris. Okay. Okay. Then we go to the next step. Explain briefly why you like it to one of your neighbors. And maybe we'll also try the next one. Think of these 8 core drives that I've just talked about and see which ones, try to recognize which ones are present in your game. And people who are following online, maybe they can share their ideas in the chat. But the 8 core drives are related there. Meaning, empowerment, social influence, unpredictability, avoidance, scarcity, and ownership. We'll take a few minutes to do this. Doe hier even inloggen. Of ze nog wat iets willen delen? Of ik kan het ook koppelen aan de volgende. Maar. Okay, let's move on. Chow also grouped these 8 core drives into 4 categories. On the one hand, he makes a distinction between left brain and right brain core drives, where he says that the left brains are related to extrinsic motivation. So where you are being rewarded by points or gold or whatever, for example. Whereas in the right brain core drives, they're related more to intrinsic motivation, where the motivation comes from within yourself. So in the examples that you discussed, were there examples of left brain core drives on the left side of the model? Or were they more on the right? Does anybody have an example? On the right, what kind of game did you have, and what was the? Mainly, I see these two topics. Okay, so that's on the other side. Okay, and then we also have the white hat and the black hat, where he says the white hat are the optimistic ones. I summarize it for myself. The motivations that make us feel powerful, fulfilled, and satisfied. And on the other hand, the black hat, the core drives that make us feel obsessed, anxious, and addicted. And if you remember, on the bottom we had things like scarcity and avoidance and unpredictability. You have to be a bit careful as a game designer. If you include too much of that, you can get a quite stressful game that not everybody will like. But on the other hand, some players may find it boring if it's all too much the white hat. Yeah. Yes. Yeah, I think so. So the white hat would be the accomplishment, meaning, and environment. Okay. Then.
So actually, the Octavis's model is a really nice model to think about when you are designing games, but also when you are preparing activities at your in education, in your classroom, or in other kinds of context. But actually, when you are teaching math, so now I'm going to ask you to move to the mathematical classroom. You need to have also some directions that help you to design games for learning, which are not always about motivation for big things, as Anders has now described, but they are there. But there is also a part of, well, what must the learners do to learn with the game? So at a smaller level, we talk actually about intrinsic integration. And intrinsic integration is actually also what you have saw. At the moment that you have a game that fits very well one of the core drives, for example, what you said about Pokemon with a scare, with one special card that connects very well with the core drive of scarcity, you have about intrinsic integration. And I will exemplify it, this intrinsic integration, with an example of a game. And this is actually a small game that was developed by one of our students. But imagine that I'm a child. So I don't have many knowledge on mathematics, but I do have this environment. And if I move the space bar, something will happen. See, I have to click on here. And and I can also move the numbers. And if I move the number, there is an error and something went wrong. Because even if I don't have much knowledge, I do want to match the diamonds. So I will try 2 and okay.
You don't see that.
So let me see. So how can we do this? Perhaps I have to stop the presentation.
Let's stream all screen.
Can you go there?
Stop and share the whole screen. Oh yeah.
I'm going to stop it.
Stop sharing.
Stop sharing, but then I have to share it.
Now we see.
Yes, now you see? Oh no. No. Okay, I will share. And I will share the whole screen, right?
I think so.
And then move to the game. Wait, do you see it? Yes. Okay, so now you see it. Okay, so what I was actually, see if it works. Yes, it works. Yeah. Okay. Yeah, so now I list. Yeah. So actually I realized that if I use a number, a positive number, it goes up. So now if I want to match the diamond, I have to go down. And if I would, then I'm down. And now if I don't know, go down. So now I need to know what kind of movement do I need to go, horizontally. So, okay, I have to start again, but now I already understand a little bit. So this should be a 2. And then I want to go down, it should be a minus. Oh, I was not fast enough. I will try once more. So it will be a 2. And yeah, it goes. Yes, I matched the diamond. Oh, -1. Yes. Oh. I did.
Now we can see something else.
Okay, now it's not. And okay, I will try again. 2. Yes. And -1. And now it has to be more stiff. Yes. And now it has to be, I think, a 0. 0. Yes. And oh no, 0. And then -2, I think. Yes. And 1 and -1. And 1. Okay, -1. And now 3. Okay, I will. Yes, good. And now? Oh, yeah. Oh.
Almost made it to the goal.
Sorry?
Full screen.
Full screen. Okay. Well, no problem, because now we have, I go again to the presentation, and I think we were somewhere here from slideshow, from current side. Like, Katja is okay? Okay. Well, so actually, what you have seen, it was, we could play this without having any mathematical knowledge. But if you think about what was the player actually doing? So the player was trying to match the direction of the arrow with a number. If the number was positive, it goes up. If the number was negative, it went down. If it was higher, it would be steeper. It was not so higher, it will be not so steep. So, and how did the game react? If you match the point, you could go further. If you didn't match the points, well, you have to start all over again. And you start again with trial and error. And if you think, what kind of mathematical thinking does the player is using? And because I have here a room full of mathematicians, perhaps someone could share his thoughts or her thoughts about it. Please. Yes, I didn't thought about it, but that's a good one. Estimation. Yeah. Yes. the coefficient of a straight line, which is very important for other mathematical topics. You wanted to say something?
Oh, exactly, yes. For learning about linear functions, you need the coefficients.
Yeah. So actually, these are some of the mathematical thinking that you can then build upon, because that will be definitely not the image that a child would have when playing the game. But as a teacher, you can then use these first experiences to build upon it. And that is actually the strong idea of understanding play and games when we have about formal education, because we have a curriculum, we have some stuff that we want to teach. And I really like the Sagan and Zimmerman model. He model actually learning through play in a very simple way. Just 3 actions. The player takes an action. The game responds. And then the player has to think about the decision, the action, the feedback, and then makes a decision. So actually, that's what we were doing actually with the other game, and we were doing loops. And you can apply this idea to actually every kind of game, of every kind of situation. So intrinsic integration is actually bringing together the game goals with the learning goals. And one of Haggood, I don't know if I can Haggood is the name of the person. He defines that there are 2 main concepts that you can find in intrinsically integrated games. The first one is that the material that you want to deliver through the parts of the game is the most fun to play. So, for example, if in the game that we played was about the slope, it was the most fun part to play, just to playing with the slope and trying to match the diamonds. The second aspect was embody learning material within the structure of the gaming world and the player's interaction with it. So actually, in this case, the learning material could be about the slope, and the interaction that were occurring in the game were helping the student to win the game. So actually mastering the concept of slope would be, in this case, mastering the game, of the other way around. In the Smart Education Lab, but also in our research group of STEM education, we have developed several games, usually with our the students from game design. These are 4 of the games that we have been working. So the Mathify Me game, we are still working on it. It's Connect. So it's a game to help students to experience less stress and anxiety in the game, in the mathematical lesson. And for example, it was a prototype of a game that we built for that. And we built a game in which there was one activity of positive psychology, where the students would be concentrating on positive emotions. So the idea was, if you have positive emotions, you will feel less stress. So again, the idea of connecting some goals with the gameplay. In the Math Dungeon, it was a social game. Actually, you want to learn through communication with each other. So in this game, children learn about algebra, but they only see part of the algebraic expression. And they have to communicate with each other to build together the solutions to algebra. So in this case, the game and mechanics, what was about, communicating with each other, would help to learn social interaction, actually. And what I want now to share with you, and it's the game of Function Dungeon, which was a game that was created for learning of linear functions. And we are working on this game for some years, and Anders will tell us about how we have proceeds for implicit integration.
Yes, it started within the Gamma European project, where we looked at different topics and distributed them among partners. And we, as Amsterdam University of Applied Sciences, wanted to do something for the topic of linear functions. And this became this game called Function Dungeon. And one of our bachelor students worked on it, Kevin Housvuur. And we focused on a couple of learning goals. One of them was this: recognize and connect different representations of linear functions. So we wanted them to be aware of the algebraic formula expression, but we also wanted to communicate about the function in textual terms, but also as a graph, and also have the values in tables. And we wanted them to be able to relate those to each other. And in the game, the player has to move around to discover math problems. And I thought this was already interesting, because if you ask students, do you want to play, or do you want to solve a math problem now? They won't be very enthusiastic. But if you hide them in a game, they will actually search for them and solve them. Especially if they need to open a door, which was the case here. Whenever you solve a problem, a door opens and you can enter the next room. But in order to get a problem, you first have to find them, and you do that by finding the right object in the room. But there are multiple objects, and when you get close to them, they may light up, and then you know you have the right one. At this point, all of the problems were stated as multiple choice questions, although they were not only using text, but also the other kinds of representations. But we thought that was a bit limited. So therefore, we started adding other kinds of problems and also other types of gameplay, and we call those mini games. And in the version 2, we had also thought of using coordinates in some of the math problems, and that relates to also where you are in the game. So a math problem could have an answer, and sometimes that would be a coordinate, and then you have to walk to that coordinate to find a nice object that could get you further in the game. And in version 3, we also had another type of intrinsic integration, where we did something with a laser that if you walk to a button, the laser turns on, but then you find out that the slope is wrong, and then you see that there's actually a formula, and that you can transform the formula by dragging stones with numbers on them. And that way you can modify the laser to direct it at the hole. And if it enters the hole, then you can escape to the next room. Yeah, all this made us aware that there's many decisions to take as a game designer. And through, we use this model also by Hunicke et al., where you, as a designer, you have to think about the game mechanics that you put in there, like navigating by walking around, by interacting through multiple choice questions, by turning on things like the laser. Those are the game mechanics. And as a player, you interact with the game, and that creates a kind of dynamics. In our game, we also have a non-player character, so also the social relation comes in there. And all of these together create a type of dynamics. And through experiencing the dynamics, you get experience certain emotions or feelings. And that is what is meant by the aesthetics. So from the designer side, mechanics, through the dynamics, you get to the aesthetic experience of the player. Then.
So amazing, the amount of knowledge that is about games and about the designing games, and also about all the things that you eventually should think about as a teacher to use games. So that is actually what started us to think about game-based teaching and game-based pedagogy. And game-based pedagogy, we define it as the knowledge of the teaching and teaching methods and also learning process involved in learning in games. This was actually our first definition. In the work of Nosian and colleagues, which are a group of researchers from Finland, they define game-based pedagogy in a more narrow way. They look to the most kind of games approaches that are used in education, and they define that as game-based pedagogy. And those are educational games, entertainment games, learning by making games, and gamification. And in all these 4 game-based learning approach, the idea of learning through play or playfulness is central, actually. And interesting is that for all these approaches, there are particular characteristics, and they also require some actions from the teachers. So I will go through all these 4 approaches, and we can reflect a little bit on it. So, for example, the first one are entertainment games. Actually, they are still the best beautiful games because they are made by professionals, by game designers. They work well. Probably all the core drives that Anders told about, we can find them there. But when you are using them in the classroom, you have to realize that they are not intended to be used in the classroom. So that the demands from the teacher to think about how can you adapt to it. But they are really nice games. For example, there are games about history, as the Assassin's Creed. Yeah, exactly. That was one of the games that one of our students from history that uses with his own students, but also Minecraft. Even Monopoly can be used also, but they are games that to be used in the classroom, they need to be adapted. The strong things of this kind of games is that you can use them for collaboration, problem solving, critical thinking, but it's very difficult to learn content, knowledge with these games. Educational games, well, we have seen already examples of it. They are you could say, the most suitable kind of games to use in the classroom. They have clear didactic goals, learning objectives. Usually they even connect with a curriculum. You can learn specific subjects. They can also be used by collaboration, communication, problem solving, critical thinking. The only thing is the integration of the content. Sometimes the games don't really match with the content, or sometimes the game can be also a little bit boring because the content is so there that it's not fun to play anymore. And also other reason is to use it in the classroom. So when you are teaching with games, there is no guarantee that your students will interpret the game and will do the activities of the game in the way that you are intended to. So this is also a challenge for educational games, to match the learning goals with the game goals. The third type is gamification. And gamification is actually add game elements to content. So you can easily add it. Actually, this is the most easier form of game-based learning to use in the classroom. You can practice content, specific skills, and I actually will share with you an example. And I'm not sure if you know Bluecut. So if you don't know Bluecut, now you're going to know Bluecut. So let me see, I will stop this first. And Katja will help me. I go where I go. Oh, just a minute. Here. Yeah. Okay, book it. So, Katja, I'm still sharing everything. Yes. Okay, great. So I'm going to host a game with you, and this is a nice one. Got quests. Okay, and let me see. This is too much. Just going to play for 3 minutes. We can do that. And I'm going to host now. So it means that you need your telephone. Actually, this was with rough tension. We're going to put favorite. People online can also do. Great. You have the question on your telephone, probably. Yeah. Seconds. So very good.
Share the second place.
Yeah. So this is a typical example of gamification. So actually you have content and you can add game elements to any content. And I will show you also the backside actually. So this is, oh no, I go again. Was here, let me see, view report. So actually this is the gratis, free. This is the free version. If I would pay, I would have more things. But you have also here, as a teacher, an overview about what students have done. In this case, what you have done, and you can also see, and this is very funny, is that well, because in this way it's okay. But the fact that you win doesn't mean always that you have the most the most correct answers. And this is a very nice feature of this game, because imagine there are these students that usually they are not very successful in classroom, and they don't even like quizzes because they are always at the bottom because they don't master the content. But in this game, it's possible that you win even if you do many things wrong, because you can stole the goal from other people. So this is a nice it's a nice experience for some students. So that's the that is something nice. And you can also, as a teacher, you can also well use this dashboard to discuss some questions that you think that's well the students didn't do well or not. Of course, that showing dashboards in the classroom is something that you should be very careful, especially nowadays, and children are very sensitive to it. So this is something that you need to be checked with your class if you can do it or not. But you can also do it as a teacher, that you hold that you know what is the leaderboard, but you don't share it with the classroom. That is also something that you should decide. The nice thing also about booklet is that booklet is just one example. You have many others. At this moment, there are many environments, applications where this is possible. And I have some students, because I give lessons of game-based pedagogy, and I have some students that use this. My students are teachers, and they use this with their students. And it's very easy because you can add questions, and you can also they have a bank of questions, actually, that you can look for topics. So it's really easy.
And you can select different game modes with the same set of questions. So we could play also a game with a dinosaur theme, where you have to crack open eggs, and it gives a different feeling with the same content.
Yeah. So probably gamification, it's not as immersive as educational games or entertainment games, but it's easier to use in a classroom context. The next one, the next approach is learning by making games.
Yeah, and that is an approach that we like very much, because it is one of the most creative, because you put your learners, your students, pupils, in the role of a game designer. So they create the game that they also play, or maybe they create a game and let their fellow students, or maybe students of a year younger, play. And the idea is that by creating a game, you really have to think deeply about the content. For example, if they would have to create a Bluecut game like this, they would need to develop questions, and maybe they need to think about, are the questions at the appropriate level? Can we create a few more difficult ones, and a few easy ones? And maybe they want to create progression through the game. This helps the students to engage deeply with the content and thereby really master the content in a way that goes beyond just learning in other ways. And they feel really motivated also, because creating a game and then letting other people play it is a very rewarding experience, if you succeed. And what is a challenge is to make this problem manageable. So a tool like Bluecut, or another environment that makes it easy to create a game, can really help in getting them to really create a game that is playable. In other instances, it may be that they only create a game idea, a game concept, and then they can still be enthusiastic about it, but they may need more time to actually finish the game to create something that is playable. Then maybe you need a few, maybe 3 2-hour sessions to create a game. But with a tool like Bluecut, you can maybe do it even within 1 lesson. And besides engaging with the content, they also learn a lot about a lot of soft skills, and digital skills, by interacting with the tools, and discussing and negotiating and planning, and creative skills. And it's always fun to see a group of students do this and the variety of results that you get. One game we often play is a simple card game. We call it Fraction War, where you draw 2 cards. One is the what is it? The denominator that's on the bottom. What is the top one again? Nominator and denominator. Okay, yeah. It's so close that I forget one. And you drew, one draws 2 cards, and the other draws 2 cards, and whoever has the biggest fraction wins all cards. And then you draw again. And that's a very simple game, but then we ask them to modify the rules. And there are tools, like we have a nice design card deck with ideas on how to modify your game. Like think about the player's skills. What can you do to make the game more difficult? Or another card is on collaboration versus competition. How can you make the game more competitive? Or can you make it more collaborative? And by letting them think about this, they can come up with variations of the game that make it more interesting. Here in Athens, people at the Technology Learning Lab have developed a couple of authoring tools. One of them is shown here, Sorbet, where you can create very simple games where things are falling and you have to drag them to the right box, the right category. And that's a very simple type of game, but it can students can really think about content and how to divide things in categories, and that it applies to many types of content, many disciplines. It can be applicable. And also in Function Dungeon, the game we've already talked about, we've created an authoring tool so that teachers or students can enter their own questions. And in addition to the 2 levels that are standard in the game that we handcrafted, we can now also generate new levels using those new questions, so that the game becomes more replayable, that you get more content and can keep playing it for longer. And we've, at the European Conference on Game-Based Learning, we came across Caroline Armachot, and she created this game of games, which is also a card deck. And she has developed a game around it that helps students create educational games by thinking about things like learning goals, a setting where it should be played, mechanics related to fun factors, components of the game, and learning tricks, which relate to learning theories. And by thinking about these cards, they can come up with a game concept quite quickly. So gameofgames.net is the website where you can find all these cards.
So we have made a tour through these 4 educational these game-based learning approaches, and so all of them are interesting and useful. Important is that as a teacher, you know them and you can make your own choices. So, for example, you would choose for educational games if you want to practice with your students specific skills, but perhaps you would choose for learning by making games if you would like to work with a whole classroom with more challenging, open activities. So, what kind of knowledge must the teacher have when it comes to game-based pedagogy? We did a project some years ago where we developed a course for mathematical teachers on game-based pedagogy. But actually, there was no pedagogical content knowledge on game-based pedagogy. So what we have done, we looked to the literature on game-based teaching, and based on what we have read, we select a number of topics. And these topics, we created a course around them. And we have been using these topics and refined our materials through the past years. So the first step that we did was actually in the Gamma project, where we came up with this idea of teaching scenarios, which are kind of lesson plans, but they are structured in a way that helps the teacher to make decisions that are important for game-based learning. So, for example, think about how I'm going to orient my students to the game goals, how I'm going to support my students during gameplay, and how can I do a debriefing with my students to ensure that the things I want them to learn have been learned? This are also described in the handbook that we have developed in this project. The second project was the game-based pedagogy in teacher education, and I'm going to share with you some information about it, because there we have to think about what are the knowledge and the competences that the teacher that would be teaching at high school would need. And we come up with these 5 topics. So the first one was learning about gameplay and gamification, really understanding how people learn through play. So, for example, one of the tasks that we have in our course was the students would play math games, and then they would discuss what kind of game mechanics would have that, and also how this would be connected with learning goals. We will use the smiley model, that is a theoretical model, came from an article that connects both things. The second topic was game analysis and examples of games, because actually you need to know many games to be able to choose, but you also need to know how can you going to select a game. So one of the examples of the models that we use was the Octausis framework. So the one that Anders described, that help us to look to games and to see what are the elements, the games that are more engaging. But also the smiley model can also help us. The third topic was about different approaches to game-based learning. That were the 4 approaches. So in our course, actually the teachers of the students, they will go through all these 4 approaches and they will experiment with them. Another topic of the 4th topic was teaching with games. And this topic is about what do you do in the classroom? So how are you going to prepare for a lesson with games? And actually we built upon the research of Kangas. It was someone that has made literature research, and she identified 4 kinds of activities that the teacher should think about it. And the first one is planning and playing. Actually, so before you start to use a game, you have to know the game and to know how you're going to connect it with your curriculum. The second activity is how you're going to orient your students to the game. And it can be in several ways. You can be explicit, but you can make also a previous activity to play with your students. Then it's about tutoring during the gameplay. Again, so what would you do? And then finally, the debriefing. So that is when there are several techniques where you can try to connect the game goals with the learning goals at the end of the game activity. And actually this theme about teaching with games, what we have done was teach what you preach. So you give lessons about games by teaching with games. And because we have few time, I'm going to make a jump. And by talking about teaching what you preach, so what we have done was these 5 subjects, we still use them in our education program on about the master education. We have a gamified course with them, and we also have teacher professional development workshops around that. And this is actually our course. It is a 1 semester course. You see that there are different colors around the rectangles, and each color corresponds to one of the 5 topics that I showed to you. And you go through the skill tree. So this is a skill tree. Partially in the classroom, so we do activities with the whole group. So, for example, you experience the group an educational escape room, or you have also a lesson in the group how you develop a game, digital game, for example. But you also have activities that you do on your own pace, and you get points for it. So, for example, you can see a film, you can read a book. So it's not only about playing games, but also that you become more game msc-ditrep, actually. And our next project, actually, it's what we are already working on, is that we are working on a kind of template that we can also, use with our students, and that our students, that our teachers, can also perhaps use them with their students to develop game activities and games for their own education. And do you want to add something?
I think for the skill tree, I think one important aspect is that it leaves some freedom for the students to choose their own route through the course. So in a way, the whole course is gamified and there's some unpredictability in it.
Yeah,
to keep it interesting.
So as a summary, so we have looked to the Smart Education Lab. We have shared our projects and also our research. We have looked to reasons to use digital game-based learning with digital between brackets. We have looked to the octalysis model, but also about intrinsic integration. And then we have looked also to game-based pedagogy. We have go through the 4 approaches. And I think now it's time for discussion. Then we can go to the panelists.
Where's the slide?
Yeah. Oh, well, people were so interested in doing all these activities that we don't have questions. Okay. And
just a remark about examples. They say that there were great examples and thanks. And the other is a question about the framework shared in the first slides. The framework by Chu.
Okay.
10 years back. Do you feel or think that in the era of AI we need to reconsider motivational drivers?
Oh, yes. You want to answer? Or you want me to answer?
Well, AI can do many things. It can help you also create a digital game. So some people are using ChatGPT or Copilot as a coding assistant to create a digital game. But yeah, you need a bit of coding experience, I think, to make that really work. There are also AI tools built into these kind of game tools. For example, there are quiz tools like Kahoot, which now come with AI built in that help you generate more questions, that you only have to say, I want my questions to be on this and this topic. But I think there's value in making your students think about the content themselves. So I wouldn't stimulate that too much. You can also look at AI on the other side to interpret behavior of players. I have some colleagues at the University of Amsterdam who are doing that. Who are trying to see if people are getting stressed during playing of the game. But I think the octalysis model and the core drives are something deeper and relate to really our motivation to do anything, not just games. So this framework is also used in other fields than gaming. You can gamify also many things in business, for example, and marketing.
And I just want to add something about it, because I think this is I was looking for the right slide that shows that learning with games is about interaction. So I think it's great that with AI you can have very quickly some game drafts, you know, and that makes possible that you in a short time can produce a prototype. But you are just producing a tool and you don't have any guarantee about how it's going to work. So, and then you still have to have your own knowledge to interpret how the students learn and to interpret how the game is having some effect or not. So yes, our answer, yes, you still need everything with AI. Please.
Thank you so much for your presentation. I found it very interesting. I'm not an expert in this. And for that reason, I'm asking just a curiosity. There is another type of game. A game that is only a context to be integrated. The sense that students are requested to explain their strategies, their choices, their ways to win their game, to arrive to a final product that is successful, and so on. Because we presented the four.
Oh.
Yes. Another kind, or this kind is spread out over the.
As a teacher, I would say I hope it's spread out, because what you described is what it means to have good education and effective learning. Well, you know, these are four. I think there will be probably much more types of approaches to game-based learning. It depends on how you look at it. It just provides a lens about how you can try to group things. Actually, this is more from the pedagogy point of view, because if you ask to a game designer to organize the field of games, you will have completely different organizations, definitely. More questions?
I also have to are there some limitation on GP?
Sorry?
What are the limitations?
Limitations of game-based learning.
And also, are there some situations where it not at all?
Good question. I've heard some students complain already, oh no, another Kahoot quiz. We've just had two this week already. So there was a time that tool was really popular among teachers. So if your students get tired of playing the same type of game in different classes, it's time to think of something else. But I think the world of games is big enough to create a lot of variation. So although I think some players have a preference for a particular type of game, they may still be willing to accept other types of games in an educational context.
I think the limitation has to do with your goals. I think if it doesn't fit the context, if it doesn't fit somehow the learning goals, then you can ask yourself why I would use it. So, yeah.
But maybe I was just thinking it is more effective than, for example, in exploratory or inquiry situation, or consolidate knowledge. I don't know, maybe you have evidence about that.
Well, you saw.
I understand that if the learning goal is to consolidate, then but does it work the same way as other activities or other strategies? I don't know.
You mean comparison of game-based learning with other kind of strategy? Yeah, that's a good question. it's what I think it's complicated in game-based learning research is that what you call a game, you saw the difference that is between games. They are called games, but they are completely different. When you are doing a booklet, or if you are playing Monopoly, but they are all games. So it makes very complicated to think in those terms. But I don't know. To be honest, I'm not sure. I think game-based learning is one of the pedagogical tools that a teacher would have in their magic bag, as you can have inquiry-based learning, problem solving. They are all needed in education.
Integration. What do we mean if put the mathematics inside the game, the integration, or is there nothing different?
You want to answer?
If you only have multiple choice textual questions and incorporate that into a tool like Bluecut, then you don't have any intrinsic integration of the mathematical content in the game. But if you do things like we did with the linear functions, where a slope has a meaning in the game, like a bridge or the direction of a laser, or in the other game where you had to get to the right crystal, then that is more intrinsic integration. And that is about linear functions, but you can, it's more difficult, because then for every mathematical concept, you have to think about how can I translate or connect this mathematical concept to game elements.
The intrinsic integration, how do you teach them how to do this?
We did this with some bachelor students in communication and multimedia design. So no specialists on education, but we showed them a couple of examples. This is the kind of stuff we mean. And we were surprised by the variety of things they came up with. From amusement parks, where everything had to do with linear functions, to space travel concepts, where also the concept reappeared in different forms.
But it's a really nice question. What you posed, because it's not easy to teach. Actually, I was thinking about there is a paper from CAFI, I think from the end of the 90s, where she did an experiment with teachers and students developing their own games. And the first games were awful. There was no intrinsic integration. So even the teachers could not design a game with intrinsic integration. But then through the cycles, they were becoming better and better. So it was a process of trial and error, actually. But it was, I can share with you this reference, because it's really nice. So if there is no more questions, thank you so much. And well, good luck with your game-based learning.
Thank you.